Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from three-dimensional geometry. And here we are going to discuss this problem where we have to find the equation of a plane which contains this line, that is x plus 3y plus 2z minus 5 is equal to 0, and 2x plus 3y plus z minus 4 is equal to 0. So here we are given the equation of the line as a combination of two planes, right? So here we have two planes, and the combination of these two planes represent a line, and this plane whose equation is to be obtained is parallel to this line. And here the equation of the line is given in symmetric form, right? And later on we'll also modify this equation. Okay, so now here we have to find the equation of a plane which contains this line and which is parallel to this line. Now let us consider the equation of two planes, right? Suppose the first plane is given by say a1x plus b1y plus c1z plus d1 is equal to 0, and the second plane is a2x plus b2y plus c2z plus d2 is equal to 0. Now we are given the equation of these two planes. So let us denote this plane by pi 1 and this plane by pi 2. Now the combination of the equations of two planes gives us a straight line, right? Suppose the plane pi 1 is like this. Here we are drawing a rough diagram. This is the plane pi 1, and the plane pi 2 is suppose like this is our plane pi 2. Now if we take the combination of the equations of two planes like this, then these two planes intersect in a line. So this is the line of intersection of these two planes pi 1 and pi 2, and any point which is common to this plane pi 1 and this plane pi 2 must satisfy the equation of this line. That is this line, all the points which lies on this plane pi 1 and pi 2, and the point should be common to both pi 1 and pi 2, must lie on this line that is given by the line of intersection of these two planes pi 1 and pi 2. So the intersection of any two planes gives us a straight line. So in the given problem, we are given the equations of two planes. So let us denote this plane by pi 1. So pi 1 is x plus 3y plus 2z minus 5 is equal to 0, and pi 2 is 2x plus 3y plus z minus 4 is equal to 0, and the combination of these two planes gives us the line of intersection of these two planes pi 1 and pi 2. So these two equations together represents a line, and the line is the line of intersection of the planes pi 1 and pi 2. So to get the equation of a plane which passes through the line of intersection of pi 1 and pi 2 is given by this equation, that is pi 1 plus lambda pi 2 is equal to 0, right? So this is the equation of a plane which passes through the line of intersection of these two planes pi 1 and pi 2, and here we have to find the equation of the plane containing this line, right, and which is parallel to this line. So let us assume that the equation of the plane say pi is given by pi 1 plus lambda pi 2 is equal to 0, where lambda is some scalar or it is a real number, and we have to now find out the value of this real number lambda. So now our this plane pi is the intersection of these two planes pi 1 and pi 2. So let us draw this plane like this. So this is our plane pi. So now pi 1 is given by this equation. So we have x plus 3y plus 2z minus 5, and here we have lambda, and pi 2 is given by this equation. So we have 2x plus 3y plus z minus 4 is equal to 0. So let us arrange the terms here and collecting the coefficients of x, y and z. So here we have x and here we have 2 lambda x. So we can now write 1 plus 2 lambda, and here we have x, then we have 3 plus 3 lambda, and here we have y, and here we have 2 plus lambda, and here we have z, and the constant term is minus 5 minus 4 lambda is equal to 0. So this is the equation of the plane pi, which passes through the line of intersection of these two planes pi 1 and pi 2. Now this plane pi is parallel to this line, right? So here we can write the equation of this plane, this line by say in symmetrical form, that is x minus 2 is equal to here we have 1 minus y, and here we have 3 minus z. So let us slightly modify this equation. So we have x minus 2 over 1, and here we can write y minus 1 over minus 1, and here we have z minus 3 over minus 1. So now we have written this equation in this form, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c. So the direction ratios of this line are given by 1, minus 1 and minus 1. So now this plane pi is parallel to this line. So here we can draw the plane pi, and here we have the line say L. So let us denote this line by L, and here we have the plane pi. So now this plane pi is parallel to the line L. So the normal vector to this plane pi is perpendicular to this line L. So this is the normal vector to this plane pi. Now here the direction ratios of this line L are given by 1, minus 1 and minus 1, and the direction ratios of the normal vector to this plane pi are given by the coefficients of x, y and z in the equation of this plane pi. So the direction ratios of the normal vector n are given by 1 plus 2 lambda, then 3 plus 3 lambda, and 2 plus lambda, and this normal vector n is perpendicular to the line L. So now applying the condition for perpendicularity of two vectors. So here if the direction ratios of the first vector are say a1, b1, c1, and the direction ratios of the second vector are a2, b2 and c2, then if the two vectors are perpendicular, then we have this condition, that is a1, a2 plus b1, b2 plus C1 C2 is equal to 0. So here A1 B1 C1 are 1 minus 1 minus 1, A2 B2 C2 are 1 plus 2 lambda, 3 plus 3 lambda, and 2 plus lambda. So here we have 1, then we have 1 plus 2 lambda, then we have B1 as minus 1, and B2 is 3 plus 3 lambda, and then we have C1 is minus 1, and C2 is 2 plus lambda is equal to 0. So now we have a linear equation in lambda. So let us solve this equation for lambda. So we have 2 plus here we have 1 plus 2 lambda, then we have minus 3 minus 3 lambda, and here we have minus 2 minus lambda is equal to 0. So here 2 lambda minus 3 lambda is minus lambda, and minus lambda is minus 2 lambda, and here we have 1 minus 3 is minus 2, and minus 2 it becomes minus 4. So this is minus 2 lambda is equal to 4, and from here lambda is 4 over minus 2, so lambda is equal to minus 2. So the value of lambda is equal to minus 2. Now to get the equation of the plane pi, let us substitute the value of lambda in this equation. So we have x plus 3y plus 2z minus 5, and then we have here lambda is equal to minus 2, and 2x plus 3y plus z minus 4 is equal to 0. So we have x plus 3y plus 2z minus 5 minus 4x minus 6y, and then we have minus 2z plus 8 is equal to 0. So x minus 4x is minus 3x, and 3y minus 6y is minus 3y, and then 2z and plus 2z and minus 2z get cancelled, and here we have minus 5 plus 8 is 3. So here dividing both sides by minus 3, we can now write this equation as x plus y plus here we have minus 1, that is equal to 0. So the equation of the plane containing this line and which is parallel to this line is given by x plus y minus 1 is equal to 0. So the equation of the plane pi which passes through the line of intersection of these two planes pi 1 and pi 2 and parallel to this line is given by x plus y minus 1 is equal to 0. So now here it is important to note that this equation can also be written as x plus y plus 0 z, and here we have minus 1 is equal to 0. So the coefficient of x is 1, coefficient of y is 1, and here this equation is independent of z, so we can here write 0 z, that is the coefficient of z as 0. So now the direction ratios of this normal vector to this plane pi are given by the coefficients of x, y, and z. So the direction ratios of the normal vector to this plane pi are given by 1, 1, and 0.